Hi, hi everyone. Before we move on to the next problem, there is a I just watched a YouTube video that suggests uh, before we decide on the solutions on the solutions that we want to implement, we should have explored multiple solutions and then uh, ask the interviewer which directions we should move on to. So that's something that I will do moving on from this problem. So let's get started. This is problem 49 and group anagrams. Right. Given an array of strings STRs, group the anagrams together. You can return the answers in any order. Input 1. Input STRs eat tea 10 8 net bet. Output bet net and 10 8 eat and tea. Explanations. There is no string in strs that can be rearranged to form pairs. The string NAT and TAN are anagrams as they can be arranged to form each other. The string 8, it, and T are anagrams as they can be rearranged to form each other. Input 2, strs empty string. Output empty list. Now, list of one element and the element is empty string. Input example 3. Input strs A. Output A. Constraints strs.length, which is the number of strings, is from 1 to 10 to the power of 4. For each string in strs, the length is between 0 to 100. strsi consists of lowercase English letters. Right. I think Alright, let me read the problem here. So we are given strs. Then we are going to grow it into multiple anagrams group. So given strs, we would like to return a list of anagrams. Right. Okay. I think I understand the problem now. Let me think about possible approaches. So I'm thinking that to compute, to decide on whether these are anagrams or not, we need to go through each string and then compute for each letter the number of occurrences. So we are going to need a dictionary for each string. A dictionary for each string to record the number of occurrences for each letter. And then based on that dictionary, interesting. We can decide whether uh, you can compare two different strings, and then you can check whether they have the same frequency, the frequency of the English letter. So let me write it down. Solution 1, brute force. So I'm gonna call the dictionary that store the frequency of the letter called rec. So let's write it here. FREQ of I equals a dictionary of A up until G. It's assuming that the character exists. Solution 1 is we look through all rec and then look through another rec I plus 1 up to n. Then if rec of I equals rec of j, then first of all we will need to store the groups. So let me call it right. And also we need to check whether for a particular string we have found the group for it. So we need to have a, let's see, we need to use a set for that. And then if we have found the group, then we add it into our set so that next time we don't create another new group for that anagram. Right. So let me create a, let's see, let me just call the return group. And actually, let me find an better naming here. Okay, let's just call it answers. Answer is an empty list. Then I'm gonna call the set is seen. Then we just if frequency of I is the same as frequency of J, then we can just call the current group as cur. Right, first of all, we add it into the answers. So answers dot append empty string. No, actually not an empty list. I'm gonna add the string of I. So strs I. And then when we encounter the anagram of it, we add it to the last element of the answer. So answers. Answers of I minus no other Right, so I need to take the last element, then gonna call it again, but then I append the strs of j. So overall, this will take how much time? Oh, I forgot. So I forgot that we need to add it to our scene, and then add strs. Actually, I just can just add the index instead. Right. And in the beginning, we can also check whether the I is in and I. No. A better way is just we check it whether the I is in there. If it is, then we just continue. If I in sin, then we continue. Okay. Overall, this will take like on time, and also the answers will be on, and then the scene will be on eventually. So on time and on space. Okay. So I'm thinking of another solution here. Another solution is we use a sorting algorithm. But don't forget that in the beginning, to compute the frequency, it's gonna take O and M, where M, so let's define in the beginning, N is strs dot length, and then the M is strs I dot length. Okay, now that makes more sense. Okay, oh, right, I just think of a problem here. So the ON time is not that accurate because we need to check whether the frequencies are the same. Let me just call another function here so that it's more clear what we are doing. Sim. Sorry, it gets a bit messy here, but the time complexity is ON times M because we need to check whether the frequencies are the same or not. Okay. Right, actually n times n is not that accurate either, because the dictionary itself has at most 26 elements. So let's delete it again. It should be O26n, which is the same as On time. I think that sounds reasonable. Yep. Another solution that I can think of is you can first create another array called strs sorted. So strs sorted is a list of uh, all the sorted strings in strs, meaning that we sort all the string in strs, and then we can check using equality to see whether a string is the same. If one string is the same as another one, if they are the same, then we call an anagram. Okay. So this would be in Python. We can do it like x.sort x.sorted for st for x in strs. Now, before I forget, let's put it. This one will take O n times m log m. Okay. But then in the later part, we are gonna check whether they are the same. But let me quickly Google how much time does it take. String equality complexity. Right, so checking whether the string is the same or not. We take on. Okay. So it's on. So when we do the next step, checking whether the string are equal, will take the same amount of time to check. And then the next step. Okay, let's continue with my proposed solutions here in solution 2. We look through all string. No. Can use nested loop again to see whether the string are the same or not. strs sorted I equals strs sorted of j. But then this part will take O n m time, and then this will take the space complexity is O n m the same. O n m space complexity, because we are storing a copy of the original strs. And I just noticed that in my first solution here, the space should be 2n times 26, which is n space instead. So yeah, just adding in my explanation here. Right, so let me think of further optimizations that we can do here. I don't think there is further optimizations that we can do. Um, may I ask which solutions do you prefer, or should I, and whether I should explore further optimizations here? From my opinion, I think solutions one feels more neat, and in terms of space complexity, it is a bit better. Alright, I'm going to move on to coding the solutions for the solutions one. So let's make this much more cleaner and write a proper Python-based solution. And I will digress a bit from our schedule. I just want to explore on the web whether there is a better way to check whether the dictionary is the same or not. How to check if two dictionaries are equal Python. So in Python, we can do dict1 equals dict2, and then that will check whether they are the equal dictionary. Okay, good to know that. So now it will be easier to solve the problem. Wait, did I solve this? Okay, so I did it last year, but it was pretty slow. Okay, obviously let's try to do that better this time. Okay, anyway, let's do that using our solutions one. So I'm gonna create an answer list to store our return. Initialize it as until list. Then I'm gonna have a scene set equals. Just thinking that instead of using a set, I will create an empty list. No, it's not a list that is initialized to all zeros, and the zero means that let's just call it false. False. And then as long as our initialize strs, right? Then we will for loop to create our frequency. And let's first just initialize frequency as empty list. No, as right. Let's do the import, and we will use default tick from collections. So this is the same that we did in our previous problem that we have seen. Collections import default tick. Then we will create a default tick. I'm not sure if it works or not, but let's try it. So for S in strs, you're gonna check the frequency. So for C in S, let's do an enumerate. Rec of I of C plus equals 1. Right. So at the end, we will have all the frequency count of all the strings. Now let's move on to the main part of our solutions. We are gonna look through all the frequency for I in length of rec. For J in length, no, it should be a range length, range I plus 1 to length of frequency. Then I'm gonna check if sin of J this one is a bit right. So if we have sin I, then we don't need to go check, go to the second next the loop inside the first one loop. So we don't need to do the nested loop if we have seen the I. So in here I'm gonna check if sin I continue. And at the second step inside the for loop, if sin J, then we continue. Otherwise, if frequency of I is the same as frequency of J, then you can add on to our answer group. So, gonna create another list called answer group. Now better name would be a current group equals, and then we initialize it with the current string. So strsi, and then when we found the anagram that we added to our current group. So current group dot append strsj, and then once we finish the log, we add our current group to our answer. So answer dot append current group. Okay, so I just saw a phrase that I might have used earlier. Just I'm going for the first solutions. It has a slight advantage in terms of time complexity, although it's not much optimization, but it is it is better. It is in fact better than the second solution. I'm thinking there. Okay, let's move on to the next step. I think I'm here. I'm gonna say I'm thinking about whether there is a better way to implement this logic. Perhaps there is not much further optimization that I can do. Okay, I forgot to add it into our scene group. So scene of j equals true. Alright, let me quickly walk through the code to make sure I haven't missed anything. I'm gonna import default tick, create an answer list, and then I initialize the scene list to false because we haven't checked anything yet. Then I'm gonna create another list called frequency using a default tick, initialize all to default tick, and then I'm gonna check the frequency of each letter for each string that will be stored in the right list. Then I'm going to walk through all the frequency list, and then check if there is an equality in the frequency dictionary. If it is, then it is an anagram. If it is anagram, then I add it into our current group of anagram solutions. And then I also mark it as scene so that the next time I don't create a new group, a new anagram group with the same subset of string, right? And then at the end, I'm gonna append the current group to our final solutions. I think that should work. So let me quickly code this out into our interface. No, actually, I missed this step. Let me test some code using our test cases. So in the first one, we have it t 10 it net that. Then I'm assuming these are all producing the string. I just walk through the first part of creating the frequency. So the first part, I enumerate all the STRS elements Another part is character. I create the frequency mapping. That should work. And then the second step, I'm gonna look through all the frequency. If I've seen it, then initially I have a group it, and then I see that P is an anagram, and then 8. So I'm gonna cross it to mark it as seen here. And then we got 10 and net. And then at the end we have back. Let's see if we got it right. Back net 10 ET8. Yep, so seems correct. Edge case is an empty. In this case, yep, I think it's a work. It's just an empty list. No, empty string. No, it's a list of empty string of one element. Another edge case is A. Then this case, I think so just work fine. I don't see any problem here. Now I think of some more edge cases that I might have missed. Yeah, good. I think, yeah. I think this, I'm pretty confident that this will work. Pretty confident that this will work. Should I, shall I proceed to coding the solutions? Okay. So in the beginning, I'm gonna run collections import. Now I'm gonna create the frequency of T for tick times length of STRS. Then for S in STRS, for C in S, frequency I, oops, STRS, frequency of I of C is equals 1. Then I'm gonna create the anagram group as an empty list, and get C equals initialize it into empty. Sorry, I missed this part. Strings. Then gonna go through all of them. For I in length of STRS, or J in range I plus 1 of length of SDRS. This should be minus 1 so that I don't go until the end because I don't need to. If sin of I, then I continue. Then the same here, if sin of j, then I continue. Otherwise, I'm gonna check if frequency of I equals frequency of j, then I'm gonna add it into our solutions. So let's call it anagrams equals STRS I. Oops. Yeah, the same, then we add it into our current. So STRS J. Then we add it to our sin. Sin of j equals 2. Then we appended the group into our answer list. And the group dot append the current anagrams. And at the end, we can return anagrams group. So let me test this. Valid syntax append anagrams dot append SDRS. Oops, sorry, I didn't mean to do that. Okay, what was wrong stuff? Frequency I of C. Oh, right. INT here. So I have it and that, which is not right. Okay, I'm having a doubt here if there is any issue with the creation. Sorry. The EA. Okay, so there is a problem here. EA, T, and B. Right, so this doesn't work. The initializations is not right. Because in Python, this means we are creating a copy. What we need to do is this. Yeah, so because we will create a separate frequency for each string. That is still wrong. Let me do a quick debugging here. If range string range I plus C you continue with anagram, then we have seen the anagram, the appended current string. Alright, so the initializations of anagram is in the wrong place. Should be right here. Then we test it again. The last one doesn't seem to work because we did not go through it. So instead of doing that minor speed up, just ignore that. And now we get the correct answer. Let's try. Yep. So we got our solutions, but it's pretty slow, I would say. Not sure why. Let's see how others implement this stuff. Right, so they're using a built-in. Okay, that's pretty interesting. Instead of doing that, let me just check if we can use dictionary as a key. I think this is interesting solutions. Yep, it does work. Okay, so I'm sorry, but my time complexity here is not O(n) times 26, but it's rather n squared. But right, so I miss this. Uh, this is quite an optimization here because we are just creating. Uh, we are we are grouping the anagrams at the same time. At the same time, we create. At the same time, we sort and create uh, answers. Oh, I mean the frequency. Well, in here I'm using a frequency as the key. And here they use the sorted string. So that is much more efficient than what I'm doing here. And to be fair, my solution is a bit nested, a bit more complicated because I go through all the string again and again. I'm using the scene variable to see if I have go through that particular string. That's a bit redundant. Instead of that, we can do as the one in this solution. Right. Yeah. So I definitely use a nested loop, which make it O(n) squared. Mhm. Okay, I think I got it now. So in this solution, by others, it will take O(n) times m log n. Then in mine, it will take O(n) squared. O(n) squared times 26. Yeah, this is definitely much more efficient. And in interview, whenever we came up with the solutions, as long as we get through the end, then it's pretty good. Than not having any solutions at all. So let me end this here. Thank you.